Good afternoon, my YouTube viewers. In this video, what we're going to talk about is the student's t-distribution. The student's t-distribution is a continuous probability distribution used when estimating the mean of a population, where the sample size is small and or the population variance is unknown. It is similar in shape to the normal distribution, but it has heavier tails. So what we're going to do is we're going to create a student's t-distribution, and we're going to use Python to do it. And so before we create the student's t-distribution, what we have to do is we have to import the libraries that we're going to need to import so that the program will execute. So the first library that we're going to import is NumPy, which is a numeric library that performs numeric calculations, creates NumPy arrays, and also creates distributions. Then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import T. So scipy is Python's scientific library. Stats is a statistical module within scipy, and T is the function that we're going to use. So now what we're going to do is we're going to set the parameters for the t-distribution. So df, that's your degrees of freedom, equals 10, and size equals 1,000. And we're going to generate the student's t-distributed data. Data equals np.random.standard t brackets df, comma, size. So standard t is your t-distribution, df is your degree of freedom, and size is your number of data points, being 1,000. So now what we're going to do after we have created the student's t-distribution, we're going to plot the histogram of the t-distribution data. So plt.figure brackets fig size equals 6,4, plt.hist, that's letting you know that you're creating a histogram, brackets data, comma, bins equals 30, comma, color equals light blue, comma, alpha equals 0.7, comma, edge color equals black, comma, density equals true, comma, label equals histogram. So now we're going to overlay a red line on the t-distribution to let you know what the t-distribution should look like. So x equals np.linespace brackets min data, comma, max data, comma, 1,000. Y equals t.pdf, and that's probability density function, brackets x, comma, df. And plt.plot, brackets x, comma, y, comma, color equals red, comma, line width equals 2, comma, label equals theoretical distribution, degrees of freedom. So we're going to customize the plot. I'm just looking at something. We're going to customize the plot, and so the title is going to be t-distribution with a font size of 16. The X label is value with a font size of 12. The Y label is density with a font size of 12. The legend has a font size of 10, and the grid has an alpha of 0.3. And we're going to show the t-distribution, and it's going to plt.show. So the histogram of the t-distribution is in blue, and the theoretical t-distribution with a degree of freedom of 10 is the red line. So you can see that the negative numbers go beyond -6, but the positive numbers go to number 4. So, but it looks to me like the mean is 0. So the t-distribution, it looks similar to a normal distribution with the exception that the tails are thicker and that's the difference between the t-distribution and the normal distribution. But I would say that the left tail on this t-distribution is longer than the right tail of the t-distribution, and I would say that you can change the t-distribution by changing the degrees of freedom. So that concludes this video on t-distributions, and the next video will be on a statistical subject, and I hope that you decide to watch it.